Oh, hi everyone. Thanks so much for showing up for your math learning. This video is a special one for Maths Mastery League participants. We completed the 2019 Gauss contest for Year 8 students last weekend, and this question was question 25. And I said at the time, I'm sure I can solve it. It's just, how would I ever do it in an hour? Like, this is one of the juiciest Gauss questions for Year 8 students that I've ever seen. So let's start by reading the description and improving our diagram, okay? So we have quadrilateral PQRS, diagonals PR and SQ intersect at O. Okay, that looks good inside PQRS. SP equals SQ equals SR equals 1. Okay, so we have SP equals SQ equals SR. Well, that's very useful. All right, it shows us that we've got some isosceles triangles happening. So that's key to the problem. We're also told that the that angle QSR is 2 times QSP. It kind of looks that way, but it's exactly twice as big. So I'm going to call this 4x, and I'm going to call this 2x. Why didn't I call them x and 2x, and why did I choose 4x and 2x? You'll see why in a second. I'm avoiding fractions. Now, once I know that, and then we're going to get to this in a second. Mark is this like math maniac, and he's gone and determined every single interior angle in here, found that all 12 of them are positive integers when the angles are expressed in degrees, and exactly 6 are prime numbers, and we have to find out how many possibilities for PQRS there are. Okay, it's fun, I promise. It was fun for me. All right, so the first thing that I'm going to do is actually I'm going to just work in here in a different color. So we're going to work in here in orange. So this is 2x. And because this is isosceles, I know this is the same as that. So that means let's call this A and A. And I'm going to use A few times, okay? So 2x plus A equals 180. All right, that means 2x plus 2a equals 180, and a equals 90 minus x. You see how I did that? I just do my algebra and rearrange. All right, so now we are going to replace that. This is now 90 minus x. I want to work in as few variables as possible. And so is this one up here. It's 90 minus x, but it's 2 angles. So I'll have to figure out how that's partitioned in just a second. Now let's work down there in black. All right, so 4x. So we're going to call this A and that A. Why am I reusing A again? Because this is all rough work. It's not really part of my solution. All right, it's just how I determine these angles. Okay, so now I got A plus 4x equals 180. And when I rearrange, I get A is equal to 90 minus 2x. So let's write that in, everybody. This one here is 90 minus 2x, as is this one, 90 minus 2x. But that one's like a partition, right? That one is split up again. Okay, so we've made some progress there. But we still don't know anything about those interior angles. And it's not immediately apparent how they're related to x. So let's call one of them y naught. Let's call that angle y. This would then be angle y because vertically opposite angles. And this one is 180 minus y. And this one is 180 minus y as well here. Right? Right. Okay. Now we got 2 variables and 2 unknowns. It's a little problematic, people. Okay? But we can now go ahead and, working in these different triangles, identify some other angles. So now that I'm working with these bisected angles, I'm going to work in blue, and I'm going to zoom in a little bit so you can see more what I'm doing. I don't know this, so call it A. And I'm going to express it in terms of these 2 angles here, okay? So I now know A plus 180 minus y plus 2x is equal to 180 because it's a big triangle, right? That's triangle POS. I'm just going to just improve my notation there. I'm just going to say that that's 180 minus y. Okay, because I just want to see that O a little clearer. All right. And so then let's solve as best we can for A. So that will make A equal to, these cancel out, y minus 2x. All right. So now we know that in terms of both y and x. Woof. Y minus 2x. I have to be very careful here. If I make a mistake while I'm talking and explaining this problem, I'll be furious. So let's see. Yeah, it's correct. All right, so that's correct. So let's remove that. It's all rough work. And then let's do this one too. Okay, so there we got y and 4x. So y plus 4x plus a for now equals 180 because it's a triangle. So A is equal to 180 minus 4x minus y. Cool. Y, sorry, no. Do this right. Don't make a mistake copying it down. 180 minus 4x minus y. All right? All right, good. Now, we're making progress, I promise. That's that angle. Now we can determine this angle here and this angle here in terms of y and x. But before we do, there's a very cool thing that we can do in this problem. And this is what made it so hard for me, but I'm going to show you right now. Notice, we've already looked at this isosceles triangle and this isosceles triangle, of course, but there's a third isosceles triangle, everyone. It's SPR is isosceles as well. And that's going to be very useful. How is that useful? Well, I know that this and this are the same. So it's going to allow me to solve one of the variables in terms of the other variable. And then I can eliminate this variable y, the second variable I introduced, so that I can then solve everything in terms of x. Woo! This is such a good question, but it's so darn hard. Okay, so let's go. Let's set up our work. So we are going to now use that. And now we're going to have a little statement, okay? Since triangle SPR is my bane of my existence, the word isosceles, ISOSC. I don't know how to spell this word yet. Since it's isosceles, I'm pretty sure that's right. Okay, then angle SPQ equals angle SPQ, not SPR, oops, don't get that wrong. SPR equals angle SRP. Okay, those angles are the same, so we write them in. Y minus 2x equals 180 minus 4x minus y. All right, now we are going to solve this for y. So let's add y to both sides and add 2x to both sides. So we get 2y is equal to 180 minus 2x. And then we divide both sides by 2. So we get y is equal to 90 minus x. Cool. It's very cool, people, okay? It's very cool. So now I can rewrite this angle in terms of x only. So instead of y, I will have there 90 minus x minus 2x. Oh, in other words, this is 90 minus 3x. So let's just keep that. All right, that's that angle. if that's 90 minus 3x and the whole thing is 90 minus x, then did you notice that this is just 2x up here? Okay, because 2x plus 90 minus 3x would be 90 minus x. All right, and then this y over here is no longer y, it's 90 minus x. And then this 180 minus x actually becomes 90 plus x. Let me prove it to you. 180 minus y equals 180 minus, always substitute into brackets, or else if you make an algebra error like that in this question at this point, I'm really sorry. I'm so sorry for you, because your algebra mistake will be so frustrating and your problem solving has been so good, but you forgot that this is 180 minus 90 plus x. Oh, that would be such a terrible thing to do. Okay, so that's 90 plus x. All right, so we're getting rid of our y's. 90 plus x. And then that one down there is just y, so it's 90 minus x. And this one is 90 plus x here. 90 plus x, that's this angle. And this is 90 minus x. This one we had 180 minus 4x minus y, and we could now just calculate it in terms of x based on these two angles. But we're not going to. We're just going to substitute in y for 90 minus x. So that's 180 minus 4x minus 90 minus x. Always substitute into brackets. This works out to be 90 minus 3x, because minus a minus is a plus. So we have minus 4x plus 1x is 90 minus 3x. So let's just improve our diagram. We're just improving our diagram all over the place, aren't we? Write that up there. 90 minus 3x. Beauty. And then the whole thing is 90 minus 2x. So that makes this one up here just x. Dun, dun, dun. All of the angles have been solved in terms of x. Now let's list them in some type of listy manner. Okay, so I'm going to list them from least complex to most complex. I have one internal angle x, this one. Okay, I have two internal angles 2x. So that's 2x here, but I have two of them. All right, don't forget, so I'm using a different color. It's very important. I have a 4x angle, just this one. And so I've done my 2x's, my 4x. Good, so that's just one. And then 90 minus x, I have how many of those? 3, it looks like. Don't count these ones. I'm going to just erase them because they're like two angles together, right? So let's get rid of those. Really get rid of them. There, that's much better. Okay. Now, so let's count our 90 minus x's. All right, so we'll put them over here. 90 minus x, we've got 1, 2, 3 of those. Okay, and then 90 plus x. We've got 1, 2 of those. And then we have 90 minus 2x, one of those. Oops. Why am I being so fussy about my colors? Minus 2x, right? Yeah, one of those. And then 90 minus 3x, so we'll just circle them as we count them. We have one of those. Now let's count up our angles. Oh wait, we have two 90 minus 3x's. 1, 2, because it was isosceles, and that's what that worked out to. Lovely. So now let's count up our angles. So I see 1, So I'm just counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. We've counted all of our angles. Lovely. Now it becomes the number theory puzzle. We've done all the geometry, everyone. The geometry part is done. Now we have to figure out what value of x makes exactly 6 of these prime. And wouldn't you know, it would be really useful to have limitations on x. Because I don't want to check all kinds of numbers. I want to check a limited list. And look at that one. What's the biggest value x can be, everybody? Did you say it has to be less than 30? Very good. Okay. All of these have to be positive integers. We were told so by the question. So, I mean, they have to be bigger than 0. So let's put a little, like, I'm going to put this here. 0 is the absolute, like, cannot be equal to x. X has to be bigger than 0. 0 is less than x, but x is also less than 30. Because if x were 30, that would be equal to 0, and that doesn't work. I mean, we can't have this thing collapsing into 0. That would be dumb. Okay, dumb might not be the right word. It would be ridiculous. So, we now have a range of x values that we should test and see which ones gives us 6 prime numbers. But the cool thing is, all right, there's some cool thing. They say the cool thing is, okay, is 4x ever going to be prime? Is this ever prime? No. There's not 4 times some number that is prime, okay? So we don't have to worry about that one at all. All right? How about 2x? Well, 2x will only be prime if x is exactly 1. So let's test it, okay? So this would be then, let x be 1, then 2x would be 2. 90 minus x is 89, but we have 3 of them. 90 plus x is 91. That's not prime, people. Okay? 91 is 7 times 13. Okay, not prime. But 89 is. Okay, 90 minus 2x is, of course, 88. That's not prime. And 90 minus 3x is 87. Yeah. Didn't work, did it? We had 4 of them being prime. No, we had 5 of them being prime. So, see, we had 3 there and 2 there. So it didn't work. X is not 1. 5 are prime. I'm hesitating because I thought that worked. Do I have an error somewhere? Anyway, let's keep going. Let's hope I don't have an error. I would really love to reshoot this whole video. Okay, so 1 didn't work. Now let's take a look at what else we notice. Okay, that means 2x can't be prime. Because the only value of 2 times something that's prime is 1, right? 2 is prime, but any other even number is not. All right, so we're down to working with these. Anyway. And then here are some things to note about these. 90 minus 2x, that will be only prime if x is equal to 44. Okay? But x can't be 44 because of this. All right? Because otherwise, this could be written as 2 times 45 minus x. And this will only be prime when it's exactly equal to 2, and 45 minus 44 gives you 1. Okay, but x can't be 44, so that's also never prime for the values of x that are possible. Okay, so we're down to only considering these. We can only consider these as possibilities. That shows us that we must be prime here and 1 of here or here. I'm I'm so frustrated because I feel as though I have an error and it's driving me nuts. If I have this error, I will be nuts. Okay, why is that? Because that's the only way to make 6, right? These two both must be prime to make 4, and then one of these. There's no other way to make 6 with 1, 2, 2, and 3. So let's keep looking. Okay, let's keep looking, everybody. So let's check some primes. If x is 2, then 90 minus x is not prime. If x is 3, 90 minus x is not prime. If x is 5, 90 minus x is not prime. If x is 7, then we have here 90 minus x gives us 83. 83 is prime. We got 4 primes. Oh, look here, 97. 6 primes. Oh, wait, 90 minus 3x, that's 90 minus 21. That gives us 69, which is not prime. We have our first value of x, so x can equal 7. We've got one. That gave us primes up top. Let's keep looking, everybody. 90 minus 3x, I can also show you another trick. Or we can just keep testing primes until we're done. I'll show you the trick at the end. Okay, so we've done 7. Let's try now 11. Okay, 90 minus 11 gives us 79. 90 plus 11 gives us 101. Yay, ding, 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 ding. Again, 6 prime angles. Isn't this fun? This is fun. This is like a cool puzzle. 13. 90 minus 13 is 77. Didn't work. Okay. So let's try. X is 17. 90 minus 17 gives us 73. We're on the road. 90 plus that is a 107. 107. Is 107 prime? It's not divisible by 3. It's not divisible by 7. And so what else would it be? Yes, it's prime. 107 is prime. So 17 works. We've found 3 of them so far. We're doing pretty good. Okay, let's try 19. 19, 71, ding, 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 109. If you said 109 is prime, you're right. It's not divisible by 7. No, it's not divisible by 7. Yeah, it's not. So that works. Okay, 19. Notice it's always those ones working, and this one, I've even stopped checking that. I should show you that I can check it, and it's not prime. I know it's not prime because of the trick I'm going to show you later. 90 minus 3 times 19 is equal to 90 minus 57, which was that 33. 33, not prime. Okay, will always be divisible by 3. Okay, let's keep going. All right, so 19 worked. Let's try 23. 23, so 90 minus 23 gives us 67, ding, ding, ding. 90 plus 3 is 113. Is 113 prime? Let's find out. It's not divisible by 3. It's not divisible by 5. It's not divisible by 2, of course. Is it divisible by... Well, what I would do is I would do 113 minus 63 gives us 50. 50 is not divisible by 7, so that's not divisible by 7. It is not divisible by 11. It's prime. Good, I don't have an error. Oh, I'm so relieved. So relieved. 23. Okay, good. I'm finding my solutions in a more efficient way this time, but I thought I remembered finding one that I didn't before. Okay. Last one to check, 29. Okay, 90 minus 29 gives you 61. Looking good. 90 plus 29 gives you 119. But it turns out 119 divided by 7 is equal to, goes in once, goes in 7 times. 7 times 17 is 119. So it ain't prime there. But this gives us 90 minus 3 times 29. That's a weird way of drawing 3 times 29. 3 times 29. 3 times 29 happens to be 87. What am I doing? Times minus 1. I don't know why I wrote that backwards. Sorry. It's 3. It worked. 6 solutions are possible. I haven't checked the actual Waterloo solution yet. I believe 6 is correct. Let's have this journey together, everybody. We're gonna take a look at the past solutions. Okay, Gauss. Look at all this math learning here. Just read it all and you'll be good at math. No, you have to try. You can't read this stuff and learn. Okay. D. 6. Woo! 7, 11, 17, 19, 23. There's 5 of them. But then, what about 29? Oh, they had it up here. We've already investigated that. Okay, yeah, I investigated it separately as well. Okay, so, yeah, they worked it all out here. Let's see if they had it. They used theta. They also used 4 theta and 2 theta instead of 4x and 2x, like it's the same, right? And I have all the same angle solved in terms of each other. So their road to a solution is probably pretty darn similar. Okay. Yeah. Yeah. Cool. So they investigate all those when they investigated the 2 theta and the 3 theta. Okay. Cool. And that was only prime when theta is 1. And so they investigate that and find that there's 5 prime numbers, 3 copies of 89. They realize all the same thing we realized. Okay, so this is very similar. Okay, thanks so much for being on that ride with me. That was a long one, but a really good one. And I hope you enjoyed it as much as I did because, I mean, I thought it was a really fun question because it blends the things I love about geometry with things I love about number theory and investigating prime numbers and cool patterns in the prime numbers. Oh man, just a great question. Can't wait to see what we get up to at the next Math Mastery League. Bye for now, everybody.